Welcome back to Physics with Captain Rod. The purpose of this video is to help with homework problems 18, 19, 20 on the Unit 5 homework here over magnetism, AC circuits, and induction. Alright, so let's see. Number 18, it says, what is the resistance of a bulb that uses average power of 25 watts when connected to a 60 Hz power source? First of all, let's talk about the 60 Hz. Okay, all this is telling us really is that this is an AC voltage. So remember that voltage comes in two types. You have DC voltage and AC voltage. Example of a DC voltage is a car battery. And remember there's a symbol for a DC voltage, this symbol here from our last unit, where this represents the positive terminal, this represents the negative terminal. And so that's a DC voltage. Then you have AC voltage. An example, well, the wall outlet here. If you look at your wall outlet and you see this little plug, that looks like this. The voltage between these two is an AC voltage. And the symbol for an AC voltage is this circle with a little squiggly in the middle. And again, the difference between them, here the voltage is always in one direction. Here the voltage varies back and forth sinusoidally, like this. Now, the frequency is referring to how many cycles per second. It's not going to be relevant in this problem. This is just how they're communicating that it's an AC voltage. Now, whenever I work these, I always like to draw a circuit diagram. It says there's a light bulb. So I'm going to go ahead and draw my circuit diagram, and I'm going to go ahead and put a resistance symbol in for the light bulb, and then an AC voltage. There's just one light bulb in this problem, so that's all our symbol, or all our circuit diagram would have. Now, it says we have a maximum voltage of 170 volts. So hopefully you've seen my video on AC voltage. You typically have two types of voltage. You have the peak or maximum voltage, and you have what's called the RMS voltage, which stands for root mean square. You want to always use this one in your calculations, and you get the RMS voltage by taking the maximum voltage and dividing by square root of 2. So in this problem, the first thing I would do is take that 170 volts, divide it by square root of 2, get the RMS voltage. And again, that's an average voltage. You should get right around 120. Now, it says the light bulb is 120 watt, I'm sorry, 25 watt bulb. Now that's what mine says. Yours may say a different value here. It's important to realize what this is. This is a unit of power. So let's start by writing out some power equations for circuits. Power is equal to current times voltage. Power is also equal to current squared times resistance. Both of these are valid. And they're valid for both DC or AC problems. There's no problem. You don't have to worry about that. The only thing is to use it for AC, the voltage and currents, they have to be RMS voltages. That's why we have to calculate this. So the power is given. Take your RMS voltage after you calculate it. You can sub that here, and you can calculate the current. For part B, it says, let's see, what is the resistance of a 60 watt bulb? Okay, so I'm not sure why they changed the wattage, but for part B, this is now going to be 60 watts. You should actually draw a new picture when doing your homework. The voltage isn't changing though. They're still running it off the same voltage source. So for part B, put your new power here, put your RMS voltage, same voltage here, calculate your new current. And then it asks for, in part B, it says the resistance of those bulbs. Well, once you have that current, you can sub it here and take your known power, sub it here, and then calculate your current. So that should be, I'm sorry, your resistance. That should be enough to get number 18 done. You can call or just post any questions if you still have trouble with it, and I'll be happy to continue to help. Okay, let's talk about 19. I'm going to get rid of this stuff here. All right, so 19. Let's see, a certain light bulb is 60 watts when operated at 120 volts. Now you'll notice that in this problem, in 19, it says operating at an RMS voltage of 120. So that's already the voltage we want. I would start number 19 with a circuit diagram picture. So it's an AC voltage. There's only one bulb, so I'm going to put a resistor symbol in for the light bulb. The voltage here is 120 volts. The resistance we do not know, but it gives us a power. Mine says 60 watts. Yours could be a different value, but that's going to be given in the problem. Now, let's see. Part A, it says, what is the peak voltage applied across the bulb? Well, the peak, or maximum, is related to the RMS by, let's see, if you take your max, divide it by root 2, or square root of 2, you get your RMS voltage. So in this problem, they're giving you the RMS voltage and asking you to calculate the peak. So you'd have to multiply both sides by square root of 2. Let's see. For part B, it says, what is the resistance of the bulb? Well, let's start with here. This is what we know about the bulb. It's 60 watts, and this is going to equal current times voltage, because remember, power is equal to current times voltage, or power is also equal to current squared times resistance. These equations are good for both DC and AC. It's just that when you're dealing with AC, you got to remember to use RMS values. So you're going to take your RMS voltage, and that's going to go here, solve for your current. And then if you want to calculate the resistance, you can use the equation 2 here, put the known power here, the current you just calculated here, and you can calculate the resistance of the bulb. For part C, repeat the process with a 100-watt bulb and just see if the resistance comes out greater or less. All right, let's chat about number 20. Now I'm going to go ahead and draw the picture for number 20. So there's a voltage source, 120 volts. Most of these are 120 volts because in the United States, our power grid is designed to be 120 volt power grid. All of your houses, those little outlets that you have to plug in lamps and refrigerators and whatnot, those are all 120 volt AC voltages. Now, in place of that light bulb, I'm going to put a resistor because the light bulbs have resistance. So this is just a generic symbol for resistance. You would put this symbol here, whether it's a light bulb or a radio or a toaster. Okay, and then we have a second bulb and a third bulb. So here's the picture, just kind of copied from the problem. Now, this one right here, it says is 120. Mine says 150 watts here, here, and a third one of 40 watts. Your values may be different, but there's powers given here, here, and here. Now I want to take this problem. I didn't do the last one, but I'm going to take the time to color code the voltages. Remember the IFACs, my IFACs video. One of them, important facts about conductors. Conductors themselves are equipotentials, and because these are all wires in theory, right? This is all copper. This is all one potential to that point there, there, and there. And again, the bottom of this is all one potential as well. So it's important to realize, right, red to black, this 120 volt potential, right, red to black, that's the potential across here. Red to black, that's the potential across here. Red to black, that's the potential across here. So this 120 volts is good across all three bulbs. Right, so again, this is an example of a parallel circuit. All your household wiring is in parallel because the voltage needs to be the same everywhere. That's the defining characteristic of a parallel circuit. For every one of these, we're given a wattage, right? So because these are in watts, those are powers. So power is equal to current times voltage. For the first bulb, take your power, plug it in there. Then because it's red to black, that's why this voltage is good here. And you can calculate a current, get a value. Repeat for the second bulb, repeat for the third bulb. You're going to get 3 currents. And as I look at this problem, it says IRMS for lamp 1. So the IRMS means, when you see this, IRMS, this means the RMS current, or root mean square current. Long story short, if you use this voltage, you're calculating the RMS current because that's an RMS voltage. So just answer questions 1, 2, and 3. And then for part B, where it says the resistance of each bulb. So again, the other equation, the other power equation we can calculate, or the other equation we can use for each bulb is this, that power is equal to I squared times R. So you can take, for example, here the 150 watts will go here. Take the known current you calculated, put it in here, and then you can solve for the resistance. And then a repeat for bulbs 2 and 3. So that should be enough, I think, to get that problem done. I think I'll stop this video right here. I hope this helps with these concepts. Have a great day.